Hello. So in today's whiteboarding session, we're going to be talking about the differences between file versus block level backups within DPX. Now, if you've ever used our DPX product, you may have noticed that there are multiple backup modes supported by DPX, namely file and block level backup. There are some additional backup modes here, image and NDMP, which we'll get to in other whiteboarding sessions. But in this demonstration, we're just going to be talking about the file versus block level backup. So what is a file level backup and what is a block level backup? A file level backup in this case is a backup at the file system. So imagine I have a file. Let's call that file A. Now, this file is going to have some collection of attributes associated with it, like a create date, a modified timestamp, an access timestamp, etc. Now, what we're namely looking at in a file level backup is changes to the file. File level backup supports multiple modes. Namely, I can do a base backup, an incremental backup, and a differential backup. So base backup is I'm backing up all the selected files from the file system. An incremental backup would be just changes from the last backup, and then a differential backup would be changes from the last base. But whenever that file changes or gets modified, uh, I'm going to be backing that file up in my incremental or differential. Now let's assume that that file, in this case, is 10 gigs in size, right? And it's a Word doc. So any change that I make to that file, let's say modify a period and change that into a comma in the file, I'm going to be backing up that 10 gig file with respect to my incremental or differential backup run. So to avoid doing that, we come to the concept of block level backup. So I only want to back up the changes necessary to make up that file. In this case, this would be uh, a backup at the block level or at the raw disk level. So imagine I take that same file A, and in the case of block level, what I'm going to do is I'm going to just draw a disk here or table that represents my underlying disk drive. So that file might consume some data blocks on that raw disk drive. Let's say these 3 data blocks here represent the file descriptor, file A. Now in a block level backup, what I'm going to be doing is just backing up and protecting those 3 data blocks. So we'll call them A, B, and C. So I'm going to be backing up and protecting these to a secondary storage disk device. Now that secondary storage disk device in a block level world is going to be either a NetApp or a DPX vStore appliance, which is running on a Linux operating system. But this file system is where I'm going to write my data blocks, A, B, and C, and store that backup as a snapshot. So at the end of that backup transfer, where I transfer those data blocks, I'm going to take a snapshot of the file system, and that snapshot is going to represent pointers pointing back to the data blocks that make up that point in time. So imagine just a set of pointers pointing back to these 3 data blocks on that vStore file system. So when a user comes along now and makes that same modification to file A, let's say changes a period into a comma, I'm going to just modify one of those data blocks, let's say C prime, um, and that block of data is the only block that's going to get transferred over in the next incremental backup, because block level backup follows a base plus incremental forever scheme. So you only have to take one base backup, and then from that point on, you're just taking the incremental changes. And once we transferred over that data block, we're going to instruct the file system to take another snapshot, and that snapshot is going to be a collection of pointers pointing to the data blocks that make up that point in time. Or in this case, A, B, and C prime are my three data blocks listed there. And on it goes. Let's say I add another data block or I make modifications to this file, maybe fill out a new data block D, transfer over data block D, and I take a new snapshot here, and that snapshot now points to A, B, C prime, and D. Okay, so very simple strategy to follow. If I ever want to delete one of these snapshots, I'm just removing those data blocks which are no longer being referenced. So if I delete my oldest snapshot listed here, I'm going to free up the disk space on that file system by removing those data blocks that I no longer need. So both A and B, you can see here, are indeed being used by my subsequent snapshots here, but data block C is not, so I'll go ahead and free that from my file system. So that is how data transfer works within a block level versus file level backup world. But it's more along the lines of the recovery that we're going to be interested in because we're able to do some very interesting things with these snapshots in a block level backup world. So we are able to mount the snapshots directly to any server in our enterprise in a process that we refer to as instant access. We're even able to use them for server imaging purposes. Um, so for example, make that snapshot into a virtual machine. We call this process virtualization. And finally, we're able to lay that snapshot down on top of a blank hard drive or bare metal machine. And we call that bare metal restore or BMR. So it's the recovery capabilities that differentiate block level backups from file level backups mostly in that we're able to mount those snapshots and treat them as primary storage in any one of these restores. At the same time, though, you are also benefiting with a block level backup uh, by being able to reduce and shorten the backup time. In our example above, we had talked about our 10 gig files. So rather than if we make a change to that 10 gig file, just a small change, rather than backing up that entire 10 gigs over and over again in our incremental or differential backups, we're going to be able to just back up the blocks that have changed within that file in a block level backup world. Thus, we can reduce the footprint that is being stored on our secondary storage device and also reduce the amount of data that's being transferred over. So from a percentage standpoint, if we assume we are in a traditional file backup space, let's say we're backing up, a base backup would be 100% of the data selection would be backed up. And then with an incremental backup, we're estimating about a third of that data, or 25 to 35% file changes occur between backups. In a block level world, we're doing a single base backup, and then since we're only capturing the block level changes from the source, we're estimating that to be anywhere between 1 to 5% block changes. So we're greatly decreasing the amount of storage that's required. We're able to increase the recovery point objective, obviously by backing up less data throughout the day. We're able to back up more times throughout the day. And also being able to decrease the recovery time objective, that is the time in which it takes to recover from that snapshot. In a file level world, we're going to have to restore each and every single individual file, whereas in a block level world, we're able to take advantage of these recovery processes known as instant access virtualization or bare metal restore.